Hi, David and Angela. Our group is Oceans 3, composed of Nishant Mehta, Masood Hosseini, and Tyler Imes. Our goal is to perform text classification on article data. Specifically, we're interested in classifying data as real news or fake news. Thus far, we've lumped together opinion articles and satire articles and called them both fake. We've then attempted to distinguish between real news and the combination of opinion and satire articles. In part 2 of the project, we're going to attempt to classify real news articles from AI-generated fake news articles. In part 3 of the project, we're going to attempt to classify real news articles against AI-generated fake news articles combined with the opinion and satire combination from part 1. And in part 4, we're going to attempt to classify real news articles from AI-generated fake news articles from opinion from satire, so a four-way text classification model in the final part. Before we were able to start modeling, we needed to gather data. The largest chunk of data we've got so far was donated to us by David from use in the Magics lab, where they're performing sentiment analysis on news data. We accessed Stargate through the cloud, and further accessed Quantum, and copied the data on our local machines. Once we got that data, we were able to use a simple regular expression to filter opinion articles from news articles, specifically using the URL. We tidied the data by sending all characters to lowercase, created the fields title, content, and content type, which is our target, and moved on to the web scraper. At this point, though, we had content types of news and opinion, with over 124,000 news articles and only around 9,000 opinion articles. Our web scraper essentially started at 3 of the Onion's main article type pages: politics, sports, and local. We took the links from each page and created a list containing links to each article whose headline was displayed on that page, along with the URL to the next page, and returned them together. We then used the get function from the requests library to scrape the content from each page in the list individually. We used the HTML function from the LXML package to find the paths in the raw content to retrieve the title and article content we wanted. We added the title and content to our existing data frame and followed the same pattern, but with the next page URL instead of the Onion section root page. We generally scraped 5 to 30 pages at a time, as every once in a while a GET request would fail and ruin that scraping session. Tedious? Yes. Overall, we ended up with around 3,100 satire articles, all cleaned and labeled with the satire content type, our target. To wrap up the first phase of our project, we did some modeling. In order to do so, we needed to slightly modify our data by relabeling our target, content type, as fake for both opinion and satire. As we've previously alluded to, we have a very imbalanced data set, with just over 12,000 fake articles, hopefully many more to come, and 124,000 news articles. With the understanding that unbalanced data isn't exactly a guarantee to negatively affect our results, we thought we should at least start off by balancing our data set. So for part 1, we're going to take around 12,000 of the real news articles and 12,000 fake news articles and create a balanced data set. Next, we needed to somehow vectorize our text so that it could be fed through our models. For part 1, we simply used what's called the bag of words approach, wherein we use scikit-learn's TF, IDF, count vectorizer, and TF-IDF transformer from the featurizer.txt library. Essentially, the bag of words approach uses the number of times each word in each article appears and takes those frequencies and creates a vector representation of each article to feed to the models. It's important to note that we'll try some more advanced embedding techniques in part 2, but we're going to go with the bag of words approach for part 1. The first type of model we created was a naive Bayes classifier. We split the training and test data into a 75-25 train test ratio split. We used our count vectorizer and our transformer to vectorize our article data and trained the model. We predicted on the test set and achieved about 75% accuracy, which was surprising, in a good way. Next, we did the same with random forests and achieved a slightly lower accuracy of around 73%. And finally, we used XGBoost and got great, so far, performance at around 80%. Coming in part 2, we're going to be using AI to generate our own fake articles. Masood's going to cover that in just a moment. We're going to use RNNs for better accuracy, and we're going to do some hyperparameter tuning, especially using a better technique than bag of words for vectorizing content. We're also going to try to mix and match some of the ways our data is split and potentially try some new types of models that we didn't try in part 1, such as maybe a support vector machine or two, just to see how it performs. We really think RNNs are going to be the way to go and are looking forward to wrapping this up in the next couple weeks. Without further ado, here is Masood to talk about how and why we are generating our own fake articles.
One of the challenges that we were dealing with in the data processing part is finding the fake data. The fake data that we were looking for needs to have some specific features. First of all, it has to be high. It has to be a high quality data because we want to compare it with the facts and with the real articles. So the more quality that the fake data have, the better the model that we end up training would be. And also, we needed to find the fake data specific to our unique purpose, which is satires and articles. So this made it a little bit difficult in order to find the right data. And then after some research, we decided to generate our own fake data. And we end up using a OpenAI GPT version 2, which has been built on top of version 1, with the difference that it has more than 10x parameters and trained on more than 10x amount of data comparing to version 1. For example, it has been trained over 8 million web pages, and these web pages have been filtered by humans. The Reddit post that used to training this model, they have received at least 3 karma. So we're dealing with very high quality data that used to train this GPT version 2 model, and that was exactly what we were looking for. There are different versions of this OpenAI GPT, and they came out in a time sequence. The current version that we are using is 774 million parameter, which is called large model, and the GPU that we're using in order to tune and generate text with this model called is the Tesla P100, and we're using 25.5 gigabytes of RAM. We couldn't make the largest version work because we needed more GPU. We needed a better GPU and more RAM. And also it takes way more time in order to generate text with the largest version. The last thing I want to talk about the model that we're using for text generation is that it uses it called masked self-attention, which all that means that it looks backward in order to predict the next word, and then after the prediction, it feeds the model with the with a new sequence of words in order to predict the next word.
Thank you, Masood. Well, that wraps it up for part 1, and part 2 will be out next week with some new models, and hopefully we can achieve some higher accuracy than we've gotten. We're impressed with what we've gotten so far and look forward to continuing working on this. Thanks.